morning, and I'm doing this video this morning live. Well, it's not live for you, it's live for me, from Mt St Helens, as you can see in the background there. And I'm just going to talk you through the formation of Mt St Helens. I'm very excited to be here today. We've been teaching this volcano at school for the past 19 years, and I finally get a chance to look at it. So I'm just going to talk you through the formation of the Cascades, and we're going to start out in the west, over there, which we can't see the coast, but over there we have got the plate margin between the North American plate and the Juan de Fuca plate. Now, the Juan de Fuca plate is an ocean crust, and that is obviously smaller and heavier and more dense than the continental crust that we're standing on now, which is the North American plate. So the Juan de Fuca plate is pushing and subducting underneath the North American plate, and we know what happens when we have a subducted plate. The plate melts and turns back into lava, turns back into magma, and the pressure and the friction means that that magma finally, over thousands of years, makes its way to the surface. And here we can see the Cascades, which is in the west coast of the US. We're about, how many miles from the coast? Here, a couple of 100 miles?
Something like that.
From the coast. So the crust has been subducted, and what we have rising to the surface is this range of mountains, which is the Cascade Mountains. And what you can see in the background is Mt St Helens. Now, we've also got Mount Adam over there. You can see just in the background over there, we've got Mount Adams over there, and then behind Mt St Helens we've got Mount Hood and a couple of other mountains, and to the north we've got Mount Rainier. So as you can see, Mt St Helens is one of the most famous volcanoes that's ever erupted, and the reason is that when the magma reached the surface, it caused lots and lots of earthquakes as the magma kind of rises up through the crust, causing the crust to kind of shake. And so that's how we know that a volcanic eruption is going to happen, because often we can monitor it on a seismograph, and we can see that something's happening with the magma chamber. So as the magma rose to the top of Mt St Helens, from the last eruption there was a volcanic plug at the top, so the lava or the magma couldn't get to the top, and it started bulging out the side to the northern flank of the volcano. This was back in 1980, and the northern part of the flank, which we're at here, we're at the north here, started to bulge out as that magma kind of couldn't make its way up and made its way to the side. And then what happened was in May, on the 18th of May, early in the morning, is that there was one last really big eruption. And what that did was, as that magma moved into the magma chamber, that eruption shook a landslide, caused a landslide on the northern flank, and that land moved down the valley. We can see lots and lots of sediment here. Some of it's from that eruption. There's a little chipmunk there in the background. And that caused the pyroclastic flow not to go upwards, which is what normally happens during a volcanic eruption, but it went sideways. It's what we call a lateral blast. So the magma and the pyroclastic flow, the hundreds and thousands of tons of hot lava and rocks that had blown off the side of the volcano, all came hurtling northwards in about a 25-mile radius all around us. And we'll turn the camera around in a minute and you'll see that the landscape, even nearly 40 years, it's the 40th anniversary, obviously next year, and we can see that the landscape still hasn't got back to normal. But as you can see here, we can see the huge crater that was left blown up the side of the volcano. And that is the difference between Mt St Helens and really any other volcano that's erupted. So here we've got Mt St Helens with the northern crater, as you can see there, that was blasted out and all of the deposition. You can see all around here how the vegetation hasn't grown back because it was completely destroyed during the eruption. An area about 25 miles square to the north of the volcano was just completely wiped out. And you can see, hopefully, that the trees are just starting to grow back, and that was nearly 40 years ago, but it's just not the same dense vegetation as you can see in the background, where we've got the really thick vegetation there. You can see still quite a lot of the tree trunks, the fossilised tree trunks are kind of everywhere, and it's kind of meadow grown up here now, but definitely not back to the forest that it was before.